Good morning, students. Today class we are going to discuss about the tree. This is the thing which we are going to discuss. So, what do you mean by tree? Tree is also a data structure concept, but already we have discussed in the first class. Uh, Data structure is majorly classified into linear and non-linear. Linear data structures like arrays, lists, stacks, and queues, and it all we have discussed already. Now, this class onwards, we are going to be discuss about the nonlinear data structure. The first nonlinear data structure is tree. So, what do you mean by tree? Tree is a nonlinear data structure used to represent relationship between elements such as records, nodes, and table of contents. A tree is an abstract model of a hierarchical structure that consists of nodes with a parent-child relationship. For this, we can take a one real-time example. Like if you are taking in your family, you can classify into grandparents, grandparents, then parents, then that particular siblings, and then children like that. This is like a family tree. Similarly, if you take your college is an example for a tree, then it is also a one hierarchical structure. The college means the college should be maintained by one particular head. That head has to manage with a different departments or a different other managerial peoples. Then it comes under the HODs, then the faculty, then classrooms like that. This type of one abstract hierarchical structure is going to be make it in a tree that usually we used to call it as a parent child relationship. That's what I have given you the first example, like a family tree. So then tree is a sequence of nodes means I told you already, it is like a one by one once a particular levels, like a sequence of nodes, like a parent, after that child, then terminal nodes like that. There is a starting node known as a root node in the tree. Always trees has to be starts with the one root node. Some trees will be like only one root node, no other children also can be taken into that, but the root node is very important in the tree. Every node other than the root has a parent node. Every node other than the root has a parent node. Nodes may have any number of children. That is a major thing we have to concentrate here. So for this, we are going to be see this example. So how to define this tree? This is the one example for the tree. See, if you see that there is a like a root node, that is A. One particular node is called A. Then it is go again. It has a three children, or a next level node like a B, C, D. Then B is again divided into some nodes, and similarly it goes like this. So that is what a tree is, a finite set of one or more nodes, such that which we have now told. No, there is a specially designated node called the root, that is nothing but a node. The remaining nodes are partitioned into n. That n should be greater than 0, means it should not be only one node, it should not be. So we are going to be make it this particular tree is in a some disjoint sets, like how we are going to be defined in T1, T2, T3, and up to Tn. So this here, in this particular example, we are taking T is going to be divided into three subtrees. Means we used to make it as a modules. These modules are going to be call it as a subtrees. Means see here, this is the terms which we are going to be see here. In the previous example, which we have told here, I have told this is a 12 nodes. It is A to G. It is A to J. It is a 12 nodes are there, and it has been divided into subtrees. In the A is a root node. Already we have discussed. The remaining nodes are going to be divided like this. See this B, whichever the B is having, how many children it is having. This is going to be a one disjoint set or a one subtree. And similarly, this D, this right side and left side is going to be then what is available in the center. It is taken like this. So by definition of each subtree is again a tree. That is, we know very well, because if you take this B is separately, this T1, if you are taking, this is also acting like a tree. So this is what we have been seeing in this. Okay. Similarly, some terminologies are some basic concepts which we are going to be discussed in the tree is what is a node. These are all some like important concepts which we are discussing now. Node. This is the main component of any tree structure. Node of a tree stores the actual data and links to the other node. Means like if you are taking in the example, A is a node or B is a node or C is a node, that should be stores the actual data, and also it is links with the others nodes also. See here, B is A is linking with B, B is linking with F, F is linking with the other node, like that. It keeps going like that. So predecessor, what do you mean by the predecessor? Every node in a tree except root has a unique parent called as a predecessor of n. In the picture, the B is the predecessor of, see this, if you are assuming this B, then B is a predecessor of E, F, and K and L. All the remaining nodes is the predecessor of this particular node. So this is the concept of predecessor. Parent. Parent of a node is the immediate predecessor of a node. In this picture, B is the parent of E and F. See here, E and F, not K and L. For K and L, we can call it as a F is a parent. But for this E and F, who is the parent? The immediate, the things which is the predecessor. Immediate predecessor is a B. So now, so this is the parent, explanation of the parent. So, root, already we have discussed, root is a first node which have no, which does not have any parent, like a it is a starting node. We can call it as a starting node, or it is the major node, which is where we are deriving from the other nodes. These, all these things are coming under the root only. Successor, which is the successor? Every node in a tree except leaf node has a unique child called as a successor. For example, E, F, K, and L are the successor of the B. How we have seen the predecessor. Similarly, in the reverse form, we can. So, what is a successor of the B means? All these are coming under the successor. Okay, everything will be coming. So, what is a child? The node which is descendant of some node is called a child node. All the nodes except root nodes are child nodes. So see here, E and F are the children of B already, which we have seen. E and F are the children of B. K and L are the children of F, not further. So these are all the some concepts. So take this as an example. From this example, this is like a small example of the tree. In this example, we are going to be see some more concepts of the tree. That is, what is a link? This is a pointer to the node of a tree. Left and right are two links of the nodes. See here, uh, here only it's example. A is the root node, and ref right and left there is a link. Okay, from this only you're going to be. So how it is creating this pointed to the no, how the nodes has been created in the left and right. This is going to be called it as a link. Degree, the maximum number of children that is possible for a node is called a degree of a node. In this picture, A is a root node, we know very well. What is the degree of this A? Means, already I told you, as per the definitions, what is a degree? Degree is nothing but a maximum number of children that is possible for a node. So maximum number of children means how many children it is having. This particular A is having B and C and D. So 3. So definitely we are telling degree of the node A is 3. So in this degree itself, we are going to be divided two types. One is the in degree, another one is the out degree. So what do you mean by the in degree? number of edges entering into the node. So number of edges which is coming into that node, entering into the node. In that picture, in degree of A is 0 because A is a starting node. It does not. It is not going to be. Nothing will be coming into that A. From A only many of the nodes are going. So okay, that's why A is in degree of A is 0. Out degree. What do you mean by the out degree? Number of edges coming out from the node. So for example, from A, B, C, D, three nodes are going out. So this is called the um, out degree of the A. Similarly, if you take what is a B in degree? B in degree is 1 because it is A to B, there is a 1 in degree, and B out degree is 2 because here E and F is there. Okay, similarly, we can see all this in degrees and out degrees. And next one is a leaf. What do you mean by the leaf? A node without children. A node without children means that is successor. It is also called a terminal node or external node. A degree of leaf node is always 0. It does not have any things. Here, see here, all these last ended nodes are degree, like a leaf, means which is terminating that particular tree. That is called a leaf. So your node without a children. So here K is not having a children, L is not having a children, G is not having a children. Similarly, all these three, H, N, I, J is not having a children. So here, these are all called a leaf node. Next, then we can call it as this leaf node as a terminal node, and also we can call known as a external node. What do you mean by the internal node? A node with at least one child or a node other than leaf node is called a internal node. So that we can call it as a, we can known as a terminal node also, non-terminal node. In this figure, A, B, C, D, E, F are internal nodes. See here, A, B, C, and D, E, F, or all the things are internal nodes, which is not which is not is acting as a leaf node. It has some children. Okay. Next, ancestor. What do you mean by the ancestor? The node M1 is said to be an ancestor of node M2 if M1 is a parent or a grandparent or grand-grandparent of M2. So we can call it as ancestor. So here, B is the ancestor of E, F, K, and L. See here, B is dividing into E and F, and again this F is dividing into K and L. Already I've told you in the real world example. So grandparent, then for this grandparent there is a one person his son may be a grandparent. Then grandparent will be having some like a parents, like a siblings, one or two brothers or something, they are siblings. Then they will be having the children like that. These the full no things whichever is coming in that all this lost nodes are taken the ancestor of B. So B is the ancestor of all these nodes. Okay. What do you mean by the descendant? Next, we are going to be discuss about the descendant. Descendant means the node M1 is said to be descendant of node M2. If the left of M2 is reachable from M2 to M1, then if you're taking this is the example, K is the descendant of F, P, A, and H is the descendant of D and A. See, K is here. So you can able to see this. K is here. The K is the descendant of FBA. FBE. Okay, FBA. You can go it like that in the left side. FBA. You can go like this. You can go like this. Okay. So next is very important thing is what is the level of tree? We used to always mention if the tree concept there we can get it always one question, that's what is the level of the tree. Level is the rank of hierarchy and root is termed as in a level 0. Okay, always the root is level termed as a 0. If a node is at level I and its child is at level I plus 1, then the parent is level of I minus 1. So usually we used to make it this concept. Okay, this is a true for all except the root node. Definitely root node will not have any hierarchy, means it is a starting node. Okay, the following nodes will be having the hierarchy of I and I plus 1, I minus 1, like this. So this level means how many nodes are present here, like a that is we are going to be considered here. Next, edge. What do you mean by the edge? The line drawn from node M1 to a binary tree is called the edge. In this particular things, edges are how it has been: A to B one edge, A to D one edge. So 1, 2, 3, 4, 5. So 11 edges are there. Totally 12 nodes are there. 11 edges are there. So some more concepts. Path. What do you mean by the path? It is a sequence of consecutive edges from source node to destination node. In the above picture, we are going to make it as a path. Here, see here only it is there. A to B, and A is creating A to B, and B to F, and F to K, like that. This like that, one path. The length of the path is 4 because 1, 2, 3, 4 nodes. So depth, what do you mean by the depth of the tree? Total number of edges from root node to a particular node is called a depth of the node. Okay, depth of the tree is the total number of edges from root node to a leaf node. Now we can consider depth of the tree is a total number of edges from root node to a leaf node in the longest path. We can take it as in the longest path. Depth of the root node is 0 always, because we know very well A is a starting node. The terms level and depth are used interchangeably. In this particular picture, depth of B is equal to 1 and depth of H equal to 2. See here, depth of B is 1 because only one level it is having. But depth of H, if you are taking, this is taking A and D and H, two paths. It is coming two paths. Okay, so this is the depth. Okay, next, height. What do you mean by the height? Total number of edges that lies on the longest path from any leaf node to a particular node is called a height of the node. Okay, height of a tree is the height of a root node. Height of all leaf nodes are always 0. But here, if you see that height of B, what is the height of B? See here, one is here, that leaf node is K, from K to F, F to B, there is a height here, it is a true. Similarly, height of H, if you calculate, it does not have anything. So it is having only a 0. Okay. So siblings, already we have seen that siblings, the nodes share the same parent or a children of some node are called siblings or a brothers. Like how no in our real world example, if we are no with our brothers and sisters, that is we used to call it as a sibling. Similarly, it means our parents are same. Similarly here, the E and F are the children who's having the parent, that is B. Okay, so like that E and F are siblings. Similarly, H and IJ are the siblings. H and IJ are the siblings of the D. Okay, D is the parent and this Hij are a siblings, means it has only one parent. That particular parent is having this many children. Okay. Next is the some basic terminologies of the tree. Already which we have seen. What do you mean by the subtree? Means the tree is divided into many modules, like many portions. That is partitions are going to be called as a subtree. So in a tree, each child from a node forms a subtree recursively. Usually, subtrees are recursively, it will be creating. Every child node forms a subtree on its a parent node. Like B, if you are taking from the A, B will be having the D and F, E. Then if you are taking subtree as a E, then E will be having I and J. So like this is a recursive thing. So subtrees are nothing but a partition of the major trees. Next is the forest. What do you mean by the forest? A forest is a set of disjoint trees. If if you remove a root of the tree, particular tree, the forest is created with the two trees headed by node B and C as a root. See here, for example, I have been removed this A. Then if I removed A, then B and C will be again creating one particular tree. See this type of, no, after removing your root node, then it is creating more than one trees, no, then this is like this type of things are going to be called it as a forest. Okay. A tree satisfies the following properties. It has no one designated node called the root node. Already we have discussed that has no parents. Every node except the root has exactly one parent, and a node may have a zero or more children. There is a unique directed path from the root to each node. And in the very important point in the tree is, what is the major difference between the tree and graphs are, there will be a unidirection. In the tree, we have to make it as a unidirection. But in the graph, we can make, no, sometimes we can make it as a both direction, bidirections also. But in the tree is a little different. It's a unidirection, and also in the hierarchical approach, so many advantages are, so many properties we have been seen in the tree. Okay, so that's all about the some tree basic concepts. See here, I have been given what is exactly tree we can tell it as. See here, this is exactly tree because it has a root node and it has a again another two level nodes. Then this is again creating some leaves. But see here, I told you know already this track will not that only bi-direction. So from top to bottom it has to come. No, no, from bottom to top it won't go always. So here, this is also a not tree. So this is also because these sets are somehow it has to be connected. It is not connected. It is disconnected. Then we can't take it as a, this is also a tree. Okay. Thank you, children. So that's all about some tree concepts. Next class we are going to be continuing the tree concept only.